Thank you for your kind words and for the invitation to the Earth Center and to PDR. So my name is Nuno Catarino. I'm head of the data systems actually division at Deimos, and I'm going to present the work that is being done internally, and these are the main people that have been developing activities in this area, with a lot more in the background. Nuno, Elena, Mark, and Vasco have been very active in this area. So I'll talk a little bit about the background, what we've been working on and what we're pursuing at Deimos, about the present work and the results that we've been working on, and what will be the future, where we want to go and where we think the Earth observation activity, I wouldn't call it business yet, but activities are leading to. So at Deimos, we work for the whole satellite missions pipeline, down from platforms to sensors to data access and systems and EO applications. In Lisbon, we have mostly the part of data access and systems. It's more than half of the company, and we work, in my division, we work in two main areas. One, which are the mission data systems, so the missions that the infrastructures that provide direct support to each satellite missions, and the other one is the downstream data systems, or exploitation of satellite data, which cover several sensors, several missions, and inclusively ground segment products. For the satellite missions, this is a quite consolidated area. We have a suite of products called GS4EO, ground segment for EO. In downstream data systems, this is the work that we've been doing in the past 7 or 8 years, mainly, trying to consolidate a little bit the tools and the methodologies that are being used here, and create what we call an ecosystem of tools, with tens and almost 100 of partners throughout Europe and outside of Europe. We are now, so the data systems division is spread across several of the Deimos companies. We are about 40 people, with 22, 23 in Lisbon, and most of the others in Madrid, and also working with the people in our branch in Arwell, which are very good in artificial intelligence, especially in applications. Typically, an Earth observation system, I wouldn't say typically, I think it's generic. So basically, the whole pipeline is you access to the data, if you can get it. You develop methods to process this data and to extract the initial information, which is typically research algorithms. Then you provide a service. That's what you aim to do to the final users, which will ideally use this towards their decision-making process. I've put in different colors each of the 4 steps. So the data issue is still an issue to have access to data. The data is very much fragmented, but there is already a lot of data that we can access to, and there's a lot of information we can extract there. Methods, I mean, there's a huge amount of funding in Europe, especially for development of techniques. So I would say that basically you have anything you need, basically you will find a method for that. And then the services or results, they imply that you have a very close connection with users. And this, I think, it's the bottleneck. So the connection with the final decision-making process. So what I believe is happening in Earth observation is you have a lot of funding being put in the technology development, but still not enough in the technology adoption. And this has to do with the nature of the institutions, mainly. Operational institutions are typically not R&D driven and don't have this availability to have this connection. So this is where we feel is the effort needs to be done in the near future, and to provide feedback on the systems that have been developed. I'll mention just 2 cases that are 2 of the more advanced cases in Earth observation. So weather Weather monitoring, this is definitely the most advanced case in Earth observation. It's already very much consolidated. And here you have, for example, hurricane detection, where you have the satellite data. You have methods to identify the hurricanes and the paths, and methodologies or models to understand where it's going. And you have a direct pipeline to public authorities and civil authorities and to the general population to provide warnings through several sources of media. So this is the whole pipeline of how our service, in my view, should work. Another one which is closely connected with optical and SAR data is the example of oil spills. EMSA, for example, in Lisbon, is very much acting and providing information to the member states on this, on the detection of oil spills. Again, the data is optical and SAR. You have algorithms for detection of oil spills using one, the other, or both data sets. And then you can identify which ship, for example, was responsible for washing their containers in the sea. This was very important in the Mediterranean. There has been a huge reduction of oil spills because of the action of EMSA. So these are two of the examples that are working. Most of them don't have the full pipeline working. These are, I'd say, the exceptions. So what have we been doing specifically on the subjects of fisheries? So I'll start first with the access to the data. So this is basically our biggest project has been next year's. One of the tasks in the project, or one of the roles of the project, is to do an European data hub where we can catalog data. We catalog it for free, and the access is for free. So we are mandated by the European Commission. We have the budget to do that, and we'll be there in the future. We've ensured that, thanks to also to the collab, that we'll have the means to keep it up for the near and hopefully the far future. So basically, this is one of the biggest, or possibly the biggest, Earth observation catalog, at least in Europe. It has about 3 million data sets, and what we do is we try to catalog the fragmented data sets. So if you have a data set, we can catalog it for you. It doesn't mean that we get a data set. You still own the data set. You have the data set on your site, but it's foundable through our system. So basically, select an area. I did this last night. So you select an area, and then you select. You do a search. This was a search, for example, here in the Azores. You have 463 results from the last 2 days, and so here. You have a centralized access point. You have a standardized way of accessing it through open search, and this is our contribution to try to defragment a little bit the access to the data. There are other issues, which is then the access to the retrieving the data itself, and this is a very complicated issue because many institutions are not available for making the data available. So that's why we also have user management system here. So basically, you can provide authorization to whoever you want who can register, and you provide authorization to access the data. So this is the upstream of the problem, let's say. Then regarding the monitoring of fishing activity, so our premises and the projects that we've been working on are all in line with the common fishing policy and the marine framework directive in Europe of combining the use of marine resources and the biodiversity with the sustainability of the ocean. So the goal is always to strengthen the monitoring, as Alice was mentioning, very much in line with what she was saying, and characterize and quantify in real time or near real time the fishing pressure and the environmental actions on fishing stocks, and to raise the awareness of what are the consequences of what is being done, and to try to mitigate that, or provide tools to mitigate those actions. So one of the activities we've been doing with the Hydrographical Institute and IPMA, with the support of the GRM, was this activity, Sea-Motion, where for the central and south continental coast in Portugal, we assessed for sardine and mackerel the correlation between the species in the fishing logbooks, which are fished by the fishermen. This data was provided to us anonymized by the GRM, and we correlate that with the conditions of bathymetry, surface dynamics, chlorophyll, and sea surface temperature. And here we basically have an assessment of the areas in red are the ones where we can expect to find higher fish stocks according to this technique, which is not the absolute truth, but it gives you already some information there. And mostly the correlation here was related to the bathymetry. There is also a very interesting work. I couldn't find the snapshot for that, but there's also very interesting work where we sort of got some inspiration done by NOAA and some other universities where they do this for a lot more variables and a lot more species, and they also are able to minimize the bycatch using this kind of techniques. So this is one of the approaches that we're following, and the other one where we're working with IPMA as well and with the government of the Azores here in a project called E-Shape for Eurogeo. Here we're focusing on two species of tuna, on tuna and swordfish. So these are the major catches here in the region. So you can see here the percentages of catches from each species. And here we analyzed the footprint for pelagic species. Forgive me if I'm going to say a mistake, but I believe this is the technique that they're using here for fishing. Is called hand-operated line and pole line fishing. So basically, you have fishermen with a fishing rod and the line on the boat fishing, as Luis was saying. So it's very selective fishing without bycatch. And so this is the distribution of the effort or the footprint for this with the data that we've been analyzing. And this is for a different technique, which is long line, set long line. I think they are drifting long lines, I believe, if I'm not mistaken. So these are typical for swordfish, and these are much more widespread. If you see here, you have the marine protected areas in this areas. You do see some fishing there, but I believe that legally there is some fishing allowed. But still, you can see the correlation or the amount of fishing statistically that is being done around the region. Here it's a particular case of set long lines. These are set long lines, so these are set in specific points. So you see that the ship comes to a surface mount and does the fishing with these long lines in these areas, then goes to another one, and then goes back. If we see in detail this area, so you see the ship comes and is working in the surface mount. This is the depth of that area, and so you can really identify, even visually, you can identify the technique that the ship is using through the path that is going for. So you do have a lot of information, both in the environmental and physical quantities that you get by satellite and information that you get also from reported position systems like VMS and AIS. In this case, I believe it's AIS systems. We've been analyzing for the whole Portuguese area since 2012 until now, basically. This is another technique. This is end lines and pole lines and operated. So this is a completely different technique where you see that the boat comes to a surface mount, and then it follows the fish schools. In this case, I believe it's typical of tuna. So it follows the fish schools in a sort of more random pattern, and then it comes back once it finishes the fishing. But again, it's always around the ocean mounts. Then another project that we have in Better, what we're doing is correlating the Sentinel data, so the data of detection of ships, visual detection, in this case through SAR, but you can do it without optical as well. We are correlating that with AIS data and VMS data. So you can see in red the detected positions of potential ships. and in green the reported positions. I have here one example. For example, here you see that there was a detection, and there is no reported position data. That either means that it's a small ship, or we can actually estimate the size, but it's either a small ship that is not required to have this data, or it can be, and you could eventually identify it through the pattern. It can be an illegal fishing vessel, for example. Here in this case, for example, you have here the detected position, and very close by SAT-AIS signal. So there is some discrepancy in time. So this is very likely the same ship. So as I said, you do have a lot of information, and on top of that, we have not been yet applying the machine learning techniques here, but we have been applying to other related areas. So in this case, it has been for identifying of trees, and especially roads and roundabouts and junctions, and containers in ships. So this can be readily applied to automate the whole process of getting warnings. The whole purpose of machine learning is not to do, it's typically doing something that a human can do, but with a lot more data. So you can filter the data so that a human can look at it afterwards. I believe we're not yet in the phase of fully automated Earth observation systems, but we can already narrow down the amount of human work that needs to be done in the background using smart techniques. This is another activity that we're using artificial intelligence in to detect sewage plumes and litter accumulation, so macro litter, but smaller than ships. So in the intertidal zones, which is very difficult to do because of the variation of these areas. This is done with the University of Portsmouth and ESA. So these are, let's say, the algorithms or project that we've been working on with several players. So typically we support very much the implementation and the operationalization, and we rely on scientific partners to work on the algorithmic side of things. So the approach that we're following, and this is always having in mind that our role as a company doing R&D in Earth observation is to systematize the work that universities and research centers are doing. So what we aim to do is to make available their work to systems that can be used in an operational setting towards decision-making processes and with a large impact. What we're doing is these services for you, which I've mentioned, which is a collaborative Earth observation ecosystem. So what is this? So basically we have an identity management system which handles authorization, security, and user management. This is already hired by ESA, and one part is already working. The other part will start having, let's say, users and being operational now in October. We have the milestone now in October, and it's going well. The other one is a store for E, also funded by an ESA project. So this is a place where we have microservices, so the kind of algorithms that I've just mentioned here. I have a couple of slides here on this, and you can sort of buy or use a very cheap algorithms with a few tens or hundreds of euros. And then further down next year, we aim to have this chain for you module where you can get these modular algorithms and chain them together into a service. So the goal is that you can make your own service with these algorithms. And by the way, the goal with the algorithms is not to have our own algorithms or to have our own services, is to have a huge number of services from many providers that want to expose their services, like they're exposing data in Next.use, they can expose the services also through the store for you, and actually monetize the services as well. So we have the possibility of also having a data lake where you can store your data, the data to your clients temporarily or permanently, and the connection with Next.use for the exposing the services and the data. And then, of course, the visualization tools. We have GeoPortal Kit that can be used, or the goal of this system is not to be a closed system, so you can choose either these tools or you can interact with your own tools. The goal is to create more activity and more systematized activity around Earth observation, so we can build a bit more of momentum towards operational services. And I think the fishing is a very good candidate. It has very interesting challenges, but also has very promising, I believe, potential. This is the look and feel of the store for EO. These are still dummy services. We don't have yet settled the final agreements for all. But the goal is it'll be a very simple website where you go there, you select what kind of algorithm you want to use, you'll have the provider, and which gives you the assurance that the algorithm is either good or not good. And you go to the algorithm, you select the area of interest, you connect it to the data that is needed to run the algorithm, you click on a button, pay, and then get the data in your FTP account or wherever you want. So this is a very one-click, one-step process that aims to make available many of the algorithms that are now being kept closed, that we want to have them here, and we have the support of Visa in this, which has been very important.
No, 1 minute.
Last slide. So this is what we aim to do, is basically to handle. So we've been working and want to continue to work with Services for EO in this strategy of handling all the pipeline from data to service. Now, as I said, we need to work, and we've been also doing this work, but need a lot more help there in the pipeline the final end of the pipeline of putting this information and added knowledge to the work of informed decisions. This is a very big effort that is required from national authorities. This is, and then we're very pleased to have the Azores region working with us in the project, because without specific knowledge and without specific information, we cannot have the added value step, which is the last one, basically. So this is what I wanted to tell you. Thank you very much.